Hey guys, welcome back to my channel. Today we'll be solving this question, the integral of log x upon 1 plus log x the whole square. And we'll be solving it by substitution and then by parts. So let's begin. Okay, so first of all, we'll be substituting log x as t, which means that the differentiation of t is 1 by x. So x dt is dx. But even though we can place this in place of dx in the integral, since we are substituting the term of x as t, we cannot have an x in the integral when everything else will be t in the form of t or in the terms of t. So we can write x as e raised to t because e is the inverse of log. So taking log to the right side, it becomes e raised to t. Now we have all the terms of x in the terms of t. So let's substitute this in the integral. So we have the integral of t upon 1 plus t the whole square into e raised to t dt. So now we're going to be writing this as two separate fractions by adding and subtracting a 1 in the numerator. So this becomes e raised to t into 1 plus t upon 1 plus t square the whole square minus 1 upon 1 plus t the whole square. When we combine these two fractions, again it becomes what we started with. So we can write it like this. We're not changing anything. So now, please observe that if we cancel out the numerator like this, 1 plus t upon 1 plus t the whole square is basically 1 upon 1 plus t because one of them gets cancelled in the denominator. So the differentiation with respect to t of 1 upon 1 plus t is minus 1 upon 1 plus t the whole square, which is what we have over here. So this fact is going to be useful to us. So let's write these two as separate integrals. One of the integral is the integral of e raised to t into 1 upon 1 plus t dt minus, actually let's keep the minus sign inside the integral, plus the integral of e raised to t into minus 1 upon 1 plus t the whole square. So now we'll start solving this integral by parts, keeping this as it is for now. So using the Lie-8 rule, I can place 1 upon 1 plus t as u because I want the differentiation of 1 upon 1 plus t since it is one of the terms that I already have. And because the exponential term comes in the end of the Lie-8 rule, e raised to t is placed as v. If you're not quite sure on how to use the Lie-8 rule or the by-parts formula, you can check out my video in which I've explained it. I'll link it in the description box and at the end of this video. So now let's start substituting our u and v in the original by-parts formula. So we have u into the integral of v minus the integral of differentiation of u into the integral of vd. So we know that the integral of e raised to t is e raised to t itself. So this stays as it is. Now we're going to be adding a constant because we just integrated something. Whenever we integrate something, we add a c minus the the differentiation of 1 upon 1 plus t is minus 1 upon 1 plus t square into the integration of this and dt. And we also have plus the integration of e raised to t into minus 1 upon 1 plus t square dt. Let me write this again. So what we've reached is e raised to t 1 plus t upon 1 plus t plus c minus the integration of minus e raised to t upon 1 plus t the whole square plus the integration of minus e raised to t upon 1 plus t the whole square. So since these two integrals are exactly the same, and this is plus, this is minus, they get cancelled out and we are left with our final answer, and it is our final answer because we have no other integral term left. So it is e raised to t upon 1 plus t plus c. But remember that we started off with terms of x. So we're going to be substituting everything back in the terms of x. E raised to t was x. T was log x. So this becomes x upon 1 plus log x plus c. And that's our final answer. So that's it for today, guys. Thank you so much for watching. I'll see you in the next video. Bye.